Hey guys, so on Tuesday we finished up our last couple lessons of that last chapter. Now we're actually going to be skipping ahead a few chapters to chapter 11, and we're going to spend a couple days on some of the lessons in this chapter, and then we'll kind of be jumping around for the rest of the year to make sure that we're hitting on some really important lessons as you move forward. So today we're going to be doing 11.1 and 11.2, which are on 11.1 is areas of parallelograms, and then the second lesson is going to be working with triangles, trapezoids, and rhombi. So first of all, areas of parallelograms. As we know, we worked earlier in the year with parallelograms. It's a shape that has four sides, it's always a quadrilateral, and it has two sets of parallel sides. So let's go ahead and get started. First, what we're going to be doing is we're going to be given a parallelogram, and we're going to be asked to find the perimeter and the area of each parallelogram. So if you remember, to find the perimeter of a parallelogram, it's just the distance around the outside of that shape. So here we're given the two outer measures. So we know if this side is 12 inches, this side is going to be 12 inches. If this one is 18, we're going to have 18 here. Because with parallelograms, the opposite sides that are parallel are also congruent. So when we find the perimeter here, we can either do 18 plus 18 plus 12 plus 12, or we can use our distributive property, and we can say 2 times 18 plus 2 times 12. Again, this is finding the perimeter. So we're going to have 36 plus 24, which is going to give us a perimeter of 60 inches. So that was kind of the easy part. Now we need to find the area. If you remember, for parallelograms, the area is equal to the base times the height, or we could say the length times the width. So here, we know what our base is. Our base is 18 inches, but we don't have our height here, because here this is a diagonal, so this is not technically the height of the figure. The height would be the length of this measure right here. Now this is where it's important to look at the information that we're given. This is a right triangle. This angle is 60 degrees. That means that this angle is going to be 30 degrees. Now, if you remember back to one of the lessons that you did on Khan Academy, you learned about special right triangles. And one of those special right triangles was a 30, 60, 90 triangle. And if you remember, that was not a very good one. Try that again. If you remember, when you're given a 30, 60, 90, draw in the square to show that it's a right triangle. When we're given a 30, 60, 90 triangle, the side opposite the 30-degree angle is x, the hypotenuse is 2 times x, and the leg that is adjacent to that 30-degree angle is going to be x times the square root of 3. So using that information, we can find our missing side lengths for this 30, 60, 90 triangle down here. Now, if our 30-degree angle is here, that means that this leg is going to be x, this leg is going to be 2x. So if this leg is 12 inches, and 12 is equal to 2 times x, that means x is going to be 6. So that leg right there is 6 inches. Then we know that this leg is x times the square root of 3. So the height of this figure is 6 times the square root of 3. Now the reason we have to use this as our height is because if you take this triangle right here and add it over here, get rid of it on this side and add it over there, we've now got a rectangle that has a length of 18 or a base of 18 and that height of 6 times the square root of 3. So now in order to find the area, we're going to do the base times the height. So 18 times 6 root 3. When we do that, we are going to get 108 times the square root of 3 inches squared. Remember, since we're working with area, your answer will always be squared. So you can give your answer there, or for today, if you want to plug it into your calculator and solve what that is, you can go ahead and do that and just go ahead and round your answer to the nearest tenth. So if we were to do that, 108 times the square root of 3 would give us 187.1 inches squared. I would take either of those answers. Really, leaving it like this gives us that exact answer. It's not rounded at all, and it takes a step away from having to plug it into your calculator to solve. So I would usually leave the answer here and leave that extra step out. So let's go ahead and do another one of these. Remember, if I'm walking through this a little too quickly for you, you can always rewind back in the video, rewatch it, and these notes are up on Schoology for you. So for this one, we have a different special triangle, special right triangle here. We know that this is 45 degrees, this is 90 degrees. So that leaves us with 45 degrees for that angle. And in a 45, 45, 90 triangle, if you remember back to those special rules for this type of triangle, you have your hypotenuse, which is x, and then your two legs are congruent to each other, and they are going to be x over the square root of 2. So in this case, I got a little ahead of myself. Again, we need to find the perimeter and the area. So in order to find the perimeter here, again, we're just adding up all of the sides. So we can do 2 times 29.6 plus 2 times 33.3, which in this case will give us a perimeter of 125.8 centimeters. Now we need to find the area. In order to find the area, again, we have the base. We need to know what the height of the figure is. And the height of the figure, like we talked about over there, is going to be x, or the length of the hypotenuse, over the square root of 2. So in this case, that will be 29.6 over the square root of 2, which gives us 20.9. So the height of our figure is 20.9 centimeters. So now in order to find the area, we're going to do base times height, which would be 33.3 times 20.9, which would give us an area of 33.3 times 20.9 gives us 695.97, which if you round that to the nearest tenth, actually rounds you to a whole number of 696 centimeters squared. So again, that's taking some of that basic knowledge that you've known for a long time of how to find areas and adding in some of the stuff we've been doing more recently of those special right triangles. Next, we're going to look at a story problem here. The Navarros are painting a room in their house. The rectangular room is 14 feet long and 12 feet wide. So if we're looking down at this room from a bird's eye view, this is the floor of the room. We know that it's 14 feet long and 12 feet wide. The walls are 10 feet high. Find the area of the walls to be painted. So we know we have two walls that are 14 feet long and two walls that are 12 feet long, and we need to paint all four walls. The walls are 10 feet high. So here I'm going to draw in, I've got one wall here that's 14 feet long and 10 feet high. And I know I have two of those walls. So times 2. Then I've got another wall that is 12 feet long and 10 feet high. And again, I know I have two of those walls. So when I find that, I'm going to multiply it by 2. Now here, what they're leaving out of it, which we're just going to ignore for now, obviously on one of these walls, there's going to have to be a door, but we're going to ignore that, and we're just going to pretend like it's a completely enclosed room and they're painting the whole inside. So for this side, we would have each wall would be 14 times 10, or 140 feet squared. And we know that we have two of those walls, so that would give us 280 feet squared. Then on this side, we've got 120 feet squared, and again, we have two of those walls, so 240 feet squared. Then we would need to add those two together, and we would get a total area that needs to be painted of 520 feet squared. So again, just working with parallelograms here, working with rectangles, being able to find the areas. So the last thing for the first lesson here is perimeter and area on the coordinate plane. So they tell us the vertices of a quadrilateral are J at -4, -3, K at 2, -3, L at 4, -6, and M at -2, -6. So the first thing they tell us to do is determine whether the quadrilateral is a square, rectangle, or parallelogram. So we know for it to be a square or rectangle, it has to have 4 90-degree angles. In this case, it does not have that. So we know out of those three, this one is going to be a parallelogram. If we wanted to test to make sure it's a parallelogram, just a reminder, you can make sure that the slopes, the opposite slopes, are equal. Obviously, these slopes are equal because they're straight lines. This one, we've got a slope of, remember, it's rise over run. So we would go down 3 over 2. So we'd have a slope of -3 over 2. Here, down 3 over 2. Again, a slope of -3 over 2. So it is a parallelogram. Next, find the perimeter of quadrilateral JKLM. So to find the perimeter here, we need to add up all of the sides. So we know that the base here is going to be 1, 2, 3, 4, 5, 6, which means this one will also be 6. Now here we need to find the length of this segment, JM and KL, in order to find our perimeter. To find the length of that, we're going to use our distance formula, which, if you remember, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So if we plug in our points here, I'm going to go ahead and use points K and L. So K was at 2, -3, and L was at 4, -6. So my distance is going to be equal to, I'm going to go ahead and use this. K is going to be 0.1 and L is going to be 0.2. So x2 minus x1 in this case would give me 4 minus 2 squared plus y2 -6 minus y1 -3. Remember, if we subtract a negative, it turns to addition. So -6 plus 3 squared. So now in this case, we're going to continue simplifying. So we've got the square root of 2 squared plus -3 squared gives us the square root of 4 plus 9, or the square root of 13. Now, if we do the square root of 13, that's going to give us 3.6. Hold on a second here. All right, so we've got our square root of, or we've got our length here is going to be 3.6. So in order to find our perimeter, it's going to be 2 times 6 plus 2 times 3.6, which will give us 12 plus, this would be 7.2. So our perimeter is going to be 19.2, and since we don't have a unit of measure, our label will be units. Then the last thing they say is to find the area of the quadrilateral. So in order to find the area, remember it's going to be the base times the height of the figure. Here for the height, we're going to have a height of 1, 2, 3 because we just want to form that 90-degree angle. It has a height of 3, so the area would be 6 times 3, which gives us an area of 18 units squared. So then for our second lesson, like I said, we're going to be doing the area of triangles, trapezoids, and rhombi. This one's going to be pretty short here, just a couple of slides. So here, find the area of quadrilateral XYZW. So we've got XYZW quadrilateral. We're going to be able to break it into a couple of different sections in order to find the area of the entire figure. So we know that XZ, which is going to be this whole length right here, is 39. We know that HW, so this area right here, is 20. And we know that YG, the height right there, is 21. Now, looking at this figure, we could break this into 2 separate triangles. I'm going to do one in green. I'm going to do triangle XZW in green. And then I'm going to have triangle XZY that I'm going to do in blue here. And we can do these because we know the area of a triangle is equal to 1/2 times the base times the height. And in these 2 larger triangles, we have the base and the height of each triangle. So for triangle XZY right here, we are going to have an area of 1/2 times the base, which is 39, times the height, which is 21. When we multiply all of that together, round to the nearest tenth, we have an area of 409.5 units squared. Then for triangle XZW, we have an area of 1/2 times the base, which again is 39, times the height, which in this case is 20. Multiply all of those together, and we have an area of 390 units squared. So if we know that this triangle is 409.5, this triangle is 390, we're going to add those together to get our total area of 799.5 units squared. So again, taking something you've worked with many times before in the past, area of a triangle, and being able to take it a step further and take a parallelogram, break it into two separate triangles, and then find the area of them, add them together to give us that total area. Then our last slide here is going to be working with area of trapezoid and area of rhombus. So for a trapezoid, the area is equal to 1/2 times the height of the trapezoid times the sum of the two bases. So 1/2 times the height times base 1 plus base 2. Area of a rhombus, we're going to have 1/2, area equals 1/2 times the diagonal 1 times diagonal 2. So, looking here, a trapezoid has two bases with measures of 25 inches and 30 inches. If the area of the trapezoid is 302.5 square inches, what is the trapezoid's height? So if you think about it, for a trapezoid, looks like this. We have base 1 and base 2, and then the height is going to be that measurement right there, straight up and down. So usually in the past when you've worked with area of trapezoid, you're given the height and the two bases, you're asked to find the area. Again, this is kind of taking it a step further. Instead of being given the bases and the height to find the area, we're given the area and the two bases, and we have to find the height. So we're going to plug in the information that we're given. We know the area is 302.5, so we're going to plug that in for A. 302.5 equals 1/2 times the height, which in this case we don't know, times base 1 plus base 2, which we know the bases are 25 and 30 inches. So now we need to solve for our h to get the height of our trapezoid. So one step at a time here, 302.5 is equal to 1/2 h times 55. Now I'm going to go ahead, since we know in multiplication we have 1/2 times h times 55. With multiplication it doesn't matter what order you go in. I'm going to go ahead and multiply those two numbers together. So 302.5, that would give me 27.5 times h. Then our last step is to get that h by itself, so we need to divide by 27.5, and we get that h is equal to 11, which we know since we're working with figures here, we always need to have a label. They're using inches up above, so the height of this trapezoid would be 11 inches. Then last one here, working with a rhombus. Again, rhombus area is equal to 1/2 times diagonal 1 times diagonal 2. So in order to solve here, we're given that one diagonal of a rhombus is bisected into two 15-centimeter portions. Now remember, if you've got a segment and it's bisected, that means that it's cut in half, meaning that these two parts are equal to each other, and they're both 15 centimeters. We know that the length of that entire diagonal then is going to be 30 centimeters. So we have that one diagonal is 30 centimeters. The area of the rhombus is 675 square centimeters. What is the length of the other diagonal? So this is similar to up above. We just need to plug in the information we're given into our formula here. So we know the area is 675. We need to multiply that by 1/2 times diagonal 1, which we can use as 30, times diagonal 2, which we don't know, we're trying to solve for. So we would have 675 equals, I want to multiply 1/2 times 30, which gives me 15 times diagonal 2. Divide both sides by 15. And I am going to end up with a length for that diagonal of 45 centimeters. Now remember, since we're just finding the diagonal, we're not finding an area anymore. We don't need to give our answer as centimeters squared. It's just going to be centimeters. So here are your homework assignments. These will be due on Tuesday. Please remember to make sure you're getting these turned in on Google Classroom. I still don't have everybody signed up on Google Classroom, which means some of you guys are missing a couple assignments now that should have been turned in on there already. So make sure you're getting on top of that. Reach out to me if you need any help with anything.